Assalamu alaikum. It's our 16th lecture of Advanced Electromagnetic Field and Waves. And in this lecture, we will continue our previous lecture. So let's start. As you know that the curl of electric field and magnetic field is, as you know that del cross E basically equals to partial P by partial T. And you also know that del cross H, which is the curl of magnetic field, it is equals to del T by del T, okay, in source free region. And you also know the harmonic is, if we write the harmonic form, so for writing the harmonic form we are assuming our wave as e power minus iota omega t, okay. So this is our wave is propagating. So in that time harmonic our equations reduces to e cross e becomes equals to iota omega mu h, okay. This is the curl of electric field, and curl of magnetic field in time harmonic should be written as equals to minus iota omega epsilon e, okay. So now let's resolve this equation first. Take this equation name as 2 and take this equation as 1, okay. So let's solve one. We have to take the cross product. How can we take the cross product of electric field? This is x, this is y, this is z, this is partial by partial x, this is partial by partial y, this is partial by partial z. Okay, becomes equals to ex, ey, and ez. This is how you can take the curl. Becomes equals to this iota omega mu, and this h becomes equals to hx plus hy plus hz. Okay, just you have to take cross product. First take this cross product, this, then take y component. You will left with x. Just take cross product. How can you take it becomes partial ez divided by partial y minus partial ey divided by partial z. Okay, similarly plus y cap, this this multiply by this multiply by this, so it becomes partial ex divided by partial z minus partial ez divided by partial x, okay. Similarly the last z can be written as partial ey divided by partial x minus partial ex divided by partial y becomes equals to this same, okay, iota omega mu hx plus hy plus hz. Now you just have to compare this first term with x component of this, y term with y component of this, and z term with just z component of this. Your next step is to just compare the x, y, and z terms. So by comparing, you will left with your first equation is this, which is equal to this. Second equation becomes equal to this becomes equal to y component of this, and this equation becomes equal to this z component of this. This factor also multiplies. So after comparing, your equations can be written as, let me write here, partial ez divided by partial y. First of all, I am writing this equation minus partial ey divided by partial z becomes equals to iota omega mu hx, iota omega mu hx. Similarly your second equation can be written as this, partial ex divided by partial z minus partial ez divided by partial x become equals to iota omega mu hy, okay. Similarly your third equation, this becomes equal to the y component, it becomes partial ey divided by partial x minus partial ex divided by partial y becomes equals to iota omega mu hz. Okay, so these are your now three equations, okay. So you can leave that equations here. Now you have to do the same scenario with these equations del cross h. Fortunately, the answer should be same, so only E left with H. So I am just writing the final equations of this equation. As we derive the relations of this, when you take the curl of magnetic field, only replacing is that here hx, hy and hz becomes, and here you will left with minus iota omega epsilon minus iota omega here epsilon, and here you will left with ex plus ey plus ez when you are solving this equation. Okay, so all the scenarios are same, only here mu change with the epsilon, and here is a negative sign because here is negative sign, and whenever there is e, it replaces by h, and the component z y x y z remains same. So let me write those equations also here. Okay, so the equations of these equations can be written as this. Okay, partial h z divided by partial y. Similarly, you can see I'm writing from his partial as because of h, so minus partial h y divided by partial z becomes equals to minus iota omega epsilon e x, as this I write. Okay, now rewrite this equation for this. It becomes, let me write here, it becomes partial hx divided by partial z minus partial hz divided by partial x becomes equals to minus iota omega epsilon ey. Same I rewrite this equation. Now rewrite this equation. So it becomes partial hy divided by partial x minus partial hx divided by partial y equals to minus iota omega epsilon, okay, ez. So three equations are these and three equations are these. Now what we have to do with these three equations, we just have to assume here that the axial side along, because we are taking this our wave, let's suppose this is our box and this is in x direction, and our wave is, let's suppose, in the z direction. So if we are assuming the axial side along z-axis, so what we have to do, we must have to travel wave along z-axis, because you can see our wave is traveling in the z-axis. So if your wave is traveling in the z-axis, therefore you have to replace partial divided by partial z must be equals to iota k, means your z component is along the propagation of wave k. Okay, so where there is partial by partial z, you only replace that term equals to iota k. You have these three and these three, so you have total six equations. Now what you have to do, where you can see partial by partial z, you have to replace it by iota k. So here I am seeing partial by partial z, here you can see, and here you can see, and here you can see partial by partial z. So now here, which I bold, you just have to put iota k here. Now let us rewrite these six equations after putting partial by partial z equals to iota k. Okay, so these are the total six equations after putting partial by partial z equals to iota k. Here you can see initially there is partial by partial z, it replaces by iota k. Here also partial by partial z, it replaces by iota k. Here you can see also there is partial by partial z, it replaces by iota k. And similar like here. And there is no partial by partial z in equation 1c and 2c, that's why there is no replacement. So these are the final six equations. With that we have to play and we have to find the expressions of ex, ey, and we have to find hx and hy. So let us first find the ex value. Okay, so our first task is to find ex. How we can find ex? To find ex, what we have to do, we have to use equation 1b and from equation 1b we have to find hy. After finding hy from equation 1b, we have to put that in equation 2a. After putting hy in equation 2a, we are find ex easily. So let's first solve equation 1b for hy. So this is equation 1b. Okay. So just rewrite this equation. Iota k e x minus partial e z divided by partial x equals to iota omega mu h y. We have to find what hy from this equation. Just divide this term to the other side. So hy becomes equals to iota k e x divided by iota omega mu. This divides by here minus partial e z divided by iota omega mu partial x. We are successfully finding hy. Our next task is to put that hy in equation 2a. So first write this equation 2a. Okay, I'm writing equation 2a, which is this, and we have to put hy in this equation. So it becomes what? It becomes like this: partial hz divided by partial y. Okay, minus iota k as it is. Hy term is this we have to put, and that is iota k e x divided by iota omega mu minus partial e z divided by iota omega mu partial x. Okay, now we have equals to this minus iota omega epsilon e of x. Now we have to solve this equation because we are finding ex, so we have to move first of all we have to multiply this with this and this with this, and then we have to move ex terms on one side because we are finding ex, and then we have to move other things to the other side, then we can easily find that terms. So just multiply these. We will get with partial hz divided by partial y plus k square ex, because iota square minus 1 and minus minus plus 1, divided by iota omega mu plus iota k partial ez divided by iota omega mu partial x, because minus minus plus and this multiply by this, and so becomes equals to minus iota omega epsilon e of x. Now move further from here because we have to find ex. Now here you can see ex and here is ex, so move this term to ex side and move this and these two terms to the other side, and move this ex term with this ex term. So let's write it here. So by taking ex common, we will left with k square divided by iota omega mu, okay, plus iota omega epsilon, which is then equals to minus partial hz divided by partial y minus partial k divided by iota omega mu partial ez divided by partial x. What I did here, like I just moved this ex term to this is ex term, and I just take ex common, and here left with k squared by iota omega mu, and here you can see when this comes here it is positive, so you left with iota omega e, so you can see iota omega e, and I just move this term to the other side, that's why here minus sign, and this term also this term I also move to the other side, also minus here. Now what is other term is to just take LCM, and then further things we have to do. So after taking LCM it becomes LCM is iota omega mu k square minus omega square epsilon mu because when taking LCM, iota square, it becomes minus 1, and omega multiplied by omega become omega square, and epsilon is already, and when take LCM, mu also becomes here, becomes equals to as it is minus partial hz by partial y minus iota k divided by iota omega mu partial ez divided by partial x. Now just multiply this term to the other side oppositely, because we have to find Ex. So Ex becomes equals to iota omega mu divided by k square minus omega if omega square epsilon mu, this multiplies by, take minus common from this, it becomes partial hz by partial y plus iota k iota omega mu partial ez by partial x. Okay, now we have to cancel this minus sign. What we have to do, we have to do again, take common minus from this denominator. Once we take common from this denominator, so this becomes positive and this becomes negative, and there is a relation that r square is equals to omega square epsilon mu minus k square. Whenever you can see this expression, you have to replace it by r square. So here you can see this equation. Okay, so what you have to do here, you can see this minus now cancels with this minus. You will only left with Ex, which is equals to iota omega mu divided by this. I told you that this becomes r square, r square. So partial hz by partial y plus you can see here it becomes what, and this iota cancels with this, you will left with k by iota mu partial ez divided by partial x. So this is your final expression of Ex. Okay, now let us find Ey, similar procedure. Okay, so now to find Ey, what we have to do now, our task is to find Ey. Okay, so to find Ey, we have to use equation 1a. Okay, and from equation 1a we have to find hx. After finding hx, we have to put that hx in equation 2b. After putting in 2b, we can successfully find the value of ey. So let's start. So our equation 1a, as you can see upright, there is written that is, you see that partial ez divided by partial y minus iota k per ey comes equals to iota omega mu h x. Okay, this is your equation 1. If you have to find hx from this equation, just divide iota omega mu to the other side. So your hx becomes equals to partial ez divided by iota omega mu partial y minus iota k ey divided by iota omega mu. Now you have to put this value of hx in equation 2b. First write equation 2b here. Here is hx, just put this value. So your equation 2b can be written as iota k and the value of hx, which is this, partial ez divided by iota omega mu partial y minus iota k ey divided by iota omega mu. Okay, minus this term as it is, partial hz divided by partial x, which is equals to minus iota omega epsilon ey. Again you have to multiply this with this and this with this. So let's multiply our equation. After multiplying, our equation becomes k divided by omega mu partial ez divided by partial y, because this iota cancels with this, only k multiplied by this, and this iota cancels by this, it becomes minus. So here you can see plus k square, because iota multiplied by iota becomes iota square, which is minus 1 multiplied by minus reverses plus 1, k square k multiplied by becomes k square ey divided by iota omega mu as it is in denominator minus partial hz by partial x as it is equals to minus iota omega e y. Now because we are finding ey, so what we have to do, we have to move ey terms on one side and other terms to the other side. This is ey term and this is ey term, so take common ey. Taking common, you will left with this k square divided by iota omega mu, and when this comes to this become positive becomes iota omega epsilon. Here you will, this comes to the other side becomes positive iota z by partial x, and this goes to other, it also becomes minus k by mu omega partial ez divided by partial y. Now again we have to take the LCM of this expression. Okay, so here e y can be written as iota omega mu divided by k square minus omega square me epsilon multiplied by partial hz by partial x minus k divided by mu omega and partial ez divided by partial y. Again, what we need, we have to make this term r square, but we know that r square is equals to omega square mu epsilon minus k square, but here we need minus here and we need plus. So how we can make, we can make by taking minus common. So by taking minus common, this relation becomes this, and this is r square, so your ey becomes left with this divided by r square, because you take minus common, and you can also take minus common from this, minus minus cancel. Once you take minus common from this, then this become positive, okay, and this become negative, so can be written as this term become first because it becomes positive because we take minus common and cancels with this minus. We also take minus common from denominator, and it becomes partial ez divided by partial y minus partial hz by partial x. So this is your final expression for ey. Okay, now we have to find the same procedure to find the expression for hx and hy. So let's start to find hx first. Now how can we find the expression for h of x, because we have to find now h of x. To find h of x, what we have to do, we have to use equation 2b, and from equation 2b we have to find e of y. After finding e of y, we have to put that ey in equation 1a. So once you put the value of ey after finding from equation 2b and put that value of ey in equation 1a, you can easily find the value of h of x. So let's start with equation 2b. As you know that equation 2b is this iota k hx minus partial hz by partial x equals to minus iota omega epsilon ey. Because we have to find ey, move divide this term to this and this also, so ey left with minus k divided by omega epsilon h of x, okay, plus 1 divided by iota omega epsilon partial h z divided by partial of x. We just divide minus iota omega e here, okay. After cancellation you will get the value of ey this. Now we have to put this value of ey in equation 1a. This is our 1a, and here you can see ey, we have to put the value of this ey in this equation. So let's do this. So it becomes partial ez divided by partial y minus iota k. I have to put the value of ey, which is this, minus k divided by omega epsilon h of x plus 1 divided by iota omega epsilon partial hz by partial x. Okay, so this is, and this also becomes equals to iota omega mu h x. You can see here. Now again we have to multiply this with this and this with this. So it becomes partial Ez divided by partial y becomes with plus iota k squared divided by omega epsilon h of x. How? Because minus minus become plus, okay, and k multiplied become k square, and minus iota k divided by iota omega epsilon partial h z by partial x become equals to iota omega mu h x, because this multiplied by this becomes minus iota, and here is also okay. Next time, as usual, you know that we have, because we are finding the value of hx, we have to move hx terms on one side and move all the other terms to the other side. So you can see here is hx term and here is hx term. Move these terms to one side and move this and this term to the other side. So let's start. So how we can do this? We are just taking hx common. After taking common, you will left with iota k square divided by omega epsilon minus iota omega mu, okay, equals to iota k. Other terms as it is can be written as iota omega, sorry, here is epsilon, partial h z divided by partial x minus partial e z divided by partial y. Now again we have to take LCM of this. So h of x becomes equals to omega epsilon iota k square minus iota omega square epsilon mu. After taking LCM, because there is no, so this multiply by this omega square, and epsilon also multiply and mu, so it becomes this equals to iota k divided by iota omega epsilon partial hz by partial x minus partial ez by partial y as it is on to the other side. Now we have to multiply this term to other side opposite, because we need hx only, so it becomes omega e divided by omega because we need to make this term becomes r. We are taking minus iota common from that equation, so you will left with omega square epsilon mu minus k square. As you know that omega square epsilon mu minus k square is always equals to r square. That's why I take minus iota common, okay, and this multiplies by this similar iota k divided by iota omega epsilon partial hz by partial x minus partial ez by partial y. Okay, now what you have to do, your final results are, this becomes, when this iota comes upside it becomes positive, so it becomes iota omega epsilon divided by this is becomes r square, so this is r square, and you will left with this iota cancels with this, you will left with k divided by omega epsilon partial hz by partial x minus partial ez by partial y. So this is your expression for the hx. Okay, now we have to do the same procedure to find the value of hy. So let's start. Okay, so now to find the value of hy, what we have to do, we have to do that we have to use equation 2a. By using equation 2a, we have to find the value of e of x. After finding the value of e of x, we have to put that value in equation 1b. Okay, so you have to find the expression of ex from equation 2a. After finding the value of ex from equation 2a, you have to put the value of ex in equation 1b. Once you put the value of ex in equation 1b, you can easily find the expression for hy. Okay, so let's start. Because you need equation 2a, so first of all rewrite the equation 2a. This is equation 2a, partial hz divided by partial y minus iota k hy comes equals to minus iota omega epsilon e of x. Because we have to find ex from this equation, you have to divide, here is minus Okay, so you have to divide minus iota omega epsilon to this side and this side also. So your Ex becomes minus 1 divided by iota omega epsilon partial hz by partial y. This is because I divide just by minus iota omega epsilon, okay, to just single this Ex, and it becomes plus iota k hy divided by iota omega epsilon. Okay, so now this is your expression of e of x. Now what you have to do, I said that you have to once find ex, you have to put this value of ex in equation 1b. So here is your equation 1b. So here is ex you have to put, so it becomes iota k. Now putting the value of ex which we find iota omega epsilon partial hz by partial y plus iota k hy divided by iota omega epsilon minus partial ez by partial x as it is equals to iota omega mu hy also as it is. Okay, now again we have to multiply this with this and this with this. So let's multiply this equation. So it becomes minus k divided by omega epsilon. Okay, partial hz by partial y. Okay, yes, we are right. Plus iota k square divided by omega epsilon par here hy. Okay, minus partial ez divided by partial x equals to iota omega epsilon hy as it is. Okay, here you can see we just multiply this with this, iota cancels with iota, you will only left with minus k, and once this you can see iota cancels with iota, so iota here and iota k square and this as it is and this as it is. Now the same thing we have to do, because we are finding the value of hy. What we have to do, we have to move this hy terms to this hy terms and move this and this term to the other side of the equals to sign. So let's do this. So as you take hy common, so you will left with iota k square divided by omega epsilon minus iota omega mu. Okay, other side is as it is, partial ez divided by partial x plus k divided by omega epsilon partial h z divided by partial y. This term is as it is. Now again you have to take LCM of this. So hy terms becomes equals to omega e, and the LCM is iota k square minus iota omega square mu epsilon, and this term as it is, partial ez by partial x plus k divided by omega e epsilon, sorry, partial hz by partial y. Okay, again we have to move this term to the other side. For that, first of all, just take minus iota common, because we need inside is omega square mu epsilon to minus k square to make it as r square divided by omega e, and equals to again partial ez divided by partial x plus k divided by omega epsilon partial hz by partial y. Again we have to move this to other side inverse to take hy alone, so hy becomes equals to omega e divided by minus iota, and this becomes r square, so r square multiplied by partial ez by partial x plus k divided by omega epsilon partial hz by partial y. Okay, and once this iota comes upside, your final expression for hy, and it can be written as iota omega epsilon divided by r square multiplied by k divided by omega e partial hz by partial y plus partial ez by partial x. So this is your final expression of hy. Okay, so that's it for finding hx hy, and we also find ex and ey. Our last part is to find the expressions for tm mode and te mode. Okay, so let's find that terms. Okay, so these are the equations which we just find. Okay, that we successfully find the expression of ex and ey. We also find it hx and hy. Okay, so these are the final results. So now our new task is to find the expressions for tm mode and te mode. So first start with tm mode. Okay, so what is tm mode? You know that it is transverse magnetic mode. Okay, in which you can say your magnetic field is transverse. Okay, and in tm mode basically your z component, because you can see our wave is propagating in the z direction, so that's why our z component of magnetic field becomes equals to 0, and electric field z component is not equals to 0 in tm mode if wave is propagating in the z direction. So for that, where there is h of z in these equations, you have to put it 0. So here you can see h of z, this becomes 0, this becomes 0, and this becomes 0, and your expressions can be written as in tm mode is iota k divided by r square partial ez divided by partial x. Okay, because this term 0, so you will only left with this, and this omega mu cancels with this omega mu, you will only left with iota k divided by r square, which I wrote here. And similarly your ey term can be written as in tm mode, and this expression becomes 0. You will only left with iota k divided by r square, because this omega mu cancels with this omega mu, you will only left with iota k divided by r square. And this partial ez divided by partial y as it is. Okay, because this hz term becomes 0, because in tm mode your hz component is 0. Similarly, you have to wrote for h of x also. In h of x, this term becomes 0, so you will left with this, and this multiplies, so you will get minus iota omega epsilon divided by r square multiplies by this term partial ez divided by partial y. This is for h of x. Similarly, for h of y, this term becomes 0, this multiplied by this, so you will left with iota omega epsilon divided by r square multiplied by partial ez divided by partial of x. So this is the expressions of ex, ey, hx and hy in tm mode. Okay, now find the same thing for te mode, transverse electric mode, in this your electric field is transverse to the wave propagation, as your wave propagation in the z direction. So as this is te mode, transverse electric, so your electric component in z component now becomes 0, and your magnetic component in z is now not 0. So now where there is ez in these equations, you have to put it 0. So here easy, here easy, here easy, and here easy. You have to put 0, and you will left your final expressions for let for your easy becomes 0. You will only left with this multiply by this, and you will get the expression of u of x is iota omega mu divided by r square partial hz divided by partial y. Similarly, for e of y, we have to find this ez becomes 0, so this multiplied by this, and there is a minus sign, so minus iota omega mu divided by r square multiplied by h z divided by h x, which is this. Now here is easy and here is easy. Now these are 0, and this multiplied by this, and this multiplied by this. This is for h of x, this is for h of y. Now write for h of x in te mode, this becomes equals to iota k divided by r square, because this omega epsilon cancels with this omega epsilon, you will only left with iota k divided by r square and partial hz by partial x as it is. And similarly write h of y component for te mode, and this becomes 0. Sorry, Ez becomes 0. You will only left with this and this. Omega E cancels with omega E. You will only left with iota k divided by r square. So here iota k divided by r square, and partial hz by partial y as it is, partial hz by partial y as it is. So these are the expressions of Ex, Ey, Hx and Hy, okay, in Tm and Te mode. You can easily see the difference that in Tm mode you can see the components of E is same, like if X, so this X component, Y, this is Y component, and electric field are same, but the magnetic field components are, you can see here is different. This is X, this Y, this is Y, but this is X. But in TE mode you can see the magnetic components are now same, X X, Y Y, but the electric component as same in TM but now different in TE mode. So you can see here if X, so it becomes Y, and Y, so X. So in TM mode your magnetic field components just changes, and electric field components remain same, but for the case of TE mode your electric field components changes but your magnetic field components not changes. So that's all for this lecture number 16. We did briefly all by, okay, step by step procedure. So that's all for today. We will upload more interesting lectures for this advanced electromagnetic field and waves course. Till then, take care. Allah Hafiz.